Welcome again to the continuation of the topic matrices. We want to see inverse of 3 by 3 matrices. In the video before this, we saw a lot of things on matrix, introduction, types, and a lot of things there. So we want to see how to get inverse of 3 by 3 matrix. What is inverse of a matrix? They say inverse of a matrix denoted by A inverse equals to 1 over determinant of the matrix times adjoint of the matrix. Now, let's see the question we have on the board and see how we can solve it. How do we solve this question? We say to solve it, we must know this formula. This is a general formula for inverse of a matrix. This is called adjoint of matrix. This is called determinant of matrix. Now, how do we get determinant of the matrix? We say determinant equals to, you bring the elements of the entries then after writing it, in the video before this, we are able to see the sign of each of the elements in this matrix. That the signs are put this way: plus, minus, plus, minus, plus, minus, plus, minus, plus. So try to check the previous video so that you see how we derive all these signs. So element 2, the first element 2 has a sign of plus. Element 1 has an intrinsic sign of minus. Element 0 has an intrinsic sign of plus, 3, minus, 1, plus, and so on. So I will now say plus, minus, plus. That is for the first element. Now, I will circle the first row. Once I circle it, then I will say, okay, when I hold the first column, when I hold it, then the first element in the first row, I will bring it, that is plus what? 2 bracket. I will now say, if I bring out this plus 2, what happens? We have 4 elements here. These 4 elements that we have remaining, we get their determinants. Determinant of a matrix says get the product of the diagonal elements and product of the off diagonal element, then subtract the 2. I repeat, determinant of 2 by 2 matrix, because this is in 2 by 2, that is 4 elements remaining. Determinant of any matrix simply means difference between the product of the diagonal elements and the off diagonal elements. So what we do is that this is diagonal element. We get the product 1 times 1, 1. You put minus, is a must. 1 times 2, 2. You bracket. Then after that, you clean the first row that you circled, and what? Circle the second column. Clean the first column that you circled and circle the second column. When you circle the second column, 4 elements will appear. Get their determinant, that is difference between the product of the diagonal elements and off diagonal elements. 3 times 1. Before you get the determinant, look at the elements on that second column. Bring it. Minus times 1, minus 1. Then 3 times 1, get the determinant now. 3 times 1, 3, minus 1 times 2, 2. Then clean the second column. Once you clean it, circle the third column. Now the element on the element on the first row of the third column is 0, plus 0. I will say plus 0 bracket. Get the determinant of the 4 elements remaining. 3 times 1, 3, minus 1 times 1, 1. Then I'll sort it out. I'll say, therefore, my det A is equal to 1 minus 2 minus 1 minus 1 times 2 minus 2. 3 minus 1, 1. 3 minus 2, 1. 1 times minus 1 minus 1. 3 minus 1, 2. 2 times 0, 0. So this will be giving you minus 3. That means the determinant of matrix A is minus 3. We go to getting the adjoints of the matrix A. For you to get the adjoints of the matrix A, you must get the cofactors of the rows. For you to get the adjoint of matrix A, you must get their cofactors of each of the elements first. After getting their cofactors, you then transpose. Then how do we get the cofactors? That is the next thing. So see how we get the cofactors. We must remember these signs. Why getting the cofactors? We say cofactors of first row. Cofactors of first row. For us to get cofactors of first row, we write 2, 1, 0, 3, 1, 2. That is the main question. 1, 1, 1. Then this is our first row. Want to get their cofactors. Now, the element on the first row is plus, minus, plus. So see how we get it? And I say equals to. Now, when I hold this point, when I hold it, I bring out the sign plus. I say plus bracket. And I say, get the determinant of this. 1 times 1, 1. 1 times this, 2. I put minus. What will it be giving me? 1 minus 2 minus 1. Minus 1 times this minus 1. Then I clean the first column and hold the second column. We are still on the first row. Then when I hold the second column, I will have 4 elements appearing. I say, what is the sign? Minus bracket. I will now say, okay, 3 times 1, 3. Okay. 1 times 2, 2. And put minus. So you do this one first. You multiply these 2 elements first before you multiply the other one. Then you put minus. This will be giving you 3 minus 2, 1. 1 times minus, minus 1. Then we say we clean the second column and hold the word third column. The element we have there has a sign plus. Plus bracket. Get the determinant. 3 times 1, 3. Minus 1 times 1, 1. That will be giving us 2. So elements we have finally for the first row is minus 1, minus 1, and 2. Okay? So we say, okay, we go to cofactors of second row. For cofactors of second row, we write everything again. 2, 1, 0, 3, 1, 1, 1, 1, 3, 1, 2, 1, 1, 1. Okay, we circle the second row. Once we circle the second row, what will happen is, we remember this is our second row. Look at their signs. We derived. We now say, okay, I will say minus is the first, plus is its next, and minus. So I'll put my bracket. Okay? So what you now do is, we now say, when you set, so once You circle the second row. What you now do is you now say the sign of the elements in the second row is minus plus minus. Then you circle the first column of the second row. 4 elements will appear. 1 times 1, 1. 1 times 0, 0. That will be giving us minus 1. Okay? We now come again. We clean the first column we circled before and circle the second column. Circling the second column. 4 elements to appear. Get their determinant. 2 times 1, 2 minus 1 times 0, 0. Everything will be what? 2. Then we clean the second column we circled and hold the third column. Okay? We now say 4 elements appear. 2 times 1, 2. 1 times 1, 1. That will be giving us minus 1. So, the elements for the second row gave us, minus 1, 2, and minus 1. We go to cofactors of the third row. Cofactors of third row. Then we write the matrix we have. That is what? 2, 1, 0. 2, 1, 0. 3, 1, 2. 1, 1, 1. So as we circle the third row, we are looking for their cofactors. What do we have as their sign? Plus, minus, plus. When I say okay, when you hold the first column, 4 elements will appear. 1, 2, 3, 4. Get the determinant. 1 times 2, 2 minus 1 times 0, 0. That will be giving me 2. Then I clean the first column I hold before. Hold the second column. Get 4 elements that appear. 2 times 2, 4. Minus 3 times 0, 0. That will be giving me minus 4. Then I'll hold the third column. When I hold it, 4 elements will appear. 2 times 1, 2, minus 3 times 1, 3. That will be giving me minus 1. So finally we have gotten answers for the third row, their cofactors. We now say, what do we have for the cofactors of third row? We have 2, minus 4, and minus 1. So let's package their cofactors. Cofactor matrix is for the first row we have minus 1, minus 1, 2. For the second row we have minus 1, 2, minus 1. For the third row we have 2, minus 4, minus 1. Then when you transpose it, you'll be getting their adjoint. Transpose. A transpose equal to adjoint of matrix A. Adjoint of A. Transpose of the cofactor. Transpose of cofactor. Equal to adjoint of matrix A. Now, how do we get it? We say adjoint of matrix A equal to transpose of any matrix simply means the row, this row you are seeing, convert it to column. We say minus 1, minus 1, 2 will be called minus 1, minus 1, 2. Minus 1, 2, minus 1 will be called minus 1, 2, minus 1. 2 minus 4 minus 1 will be called 2 minus 4 minus 1. We package it this way. This is the adjoint. This is the adjoint of the matrix. Then what you do finally is that you say A inverse equal to 1 over, what is the determinant? Determinant is minus 3 times adjunct of the matrix is minus 1, minus 1, 2, minus 1, 2, minus 4, 2, minus 1, minus 1. We now get our final answer to be this times, so 1 over minus 3 will multiply each of the elements. 1 over minus 3 times this, 1 over 3. 1 over minus 3 times this, 1 over 3. 1 over minus 3 times this, minus 2 over 3. 1 over minus 3 times this, 1 over 3. 1 over minus 3 times this, minus 2 over 3. 1 over minus 3 times this, 4 over 3. 1 over minus 6 times this, minus 2 over 3. 1 over minus 6 times this, 1 over 3. 1 over minus 6 times this, 1 over 3. So that is how to get inverse of 3 by 3 matrix. So this is the final answer to the inverse of 3 by 3 matrix. Thanks for watching the video. Please don't forget to click subscribe, like button, and comment as well. We appreciate. See you in the next video.